In this section, we will implement the coin collection functionality to enhance the gameplay experience. Players will be able to collect coins as they navigate the game, earning points to reflect their progress. We will design smooth animations for coins being collected and ensure proper interaction with the player's backpack, along with audio feedback to make the experience more engaging. In the prefabs folder, you will find a pre-configured gold coin named coin_01, which we will use for our game. Navigate to the scripts folder, right-click, and create a new script named coin. Open the script by double-clicking it in Visual Studio. First, we create a public float variable called collection radius and initialize it to 2.5, which determines the range within which the player can collect items like coins. Next, we define a public integer variable coin value and set it to 10, representing the score increment for each collected coin. We also introduce two more public float variables: animation duration, set to 0.1, which controls the time it takes for a coin collection animation to complete, and curve height, set to 0.1, which determines the peak height of the animation's curved movement. A private GameObject variable, backpack, is declared to reference the player's inventory or collection point where coins visually move upon collection. We include a private boolean is animating, initialized as false, to ensure multiple coroutines aren't triggered simultaneously during animations. To handle sound effects, we declare an audio source object named AudioSource and a public audio clip variable, AudioCoinCollection, to hold the audio clip for the coin collection sound. Next, we implement the start method, which initializes essential references when the game begins. Inside the method, we first assign the backpack variable by using GameObject. Find GameObject with tag, backpack, which searches the scene for an object tagged as backpack and stores a reference to it. Then, we initialize the audio source variable by calling getComponentAudioSource, which retrieves the audio source component attached to the same GameObject as this script. Next, we implement the calculateBézier method, which calculates a point on a quadratic Bézier curve for a given parameter t. This private method takes three vector3 parameters, p0, p1, and p2, representing the starting point, control point, and ending point of the curve, respectively. Inside the method, we first compute u as 1 minus t, where t is the normalized time. Using the quadratic Bézier curve formula, we then return the resulting point by calculating the weighted sum of the 3 points. U times p0, which represents the influence of the starting point diminishing over time, 2 times u times t times p1, which reflects the control point shaping the curve, and t times p2, which grows as the endpoint's influence increases. This method is essential for smoothly animating objects along a curved path, such as coins moving in a parabolic arc to the player's collection point. Next, we implement the collectCoin method, a private function responsible for handling the logic when a coin is collected. Inside this method, we will eventually add code to increment the player's score, though this functionality will be implemented later. For now, the method simply calls destroy GameObject, which removes the coin object from the game world. Next, we implement the animate coin to backpack method, which is a coroutine that handles the animation of a coin moving to the player's backpack in a visually appealing way. First, we set isAnimating to true to prevent multiple animations from running simultaneously. We then define the start point as the coin's current position and the static endpoint as the position of the backpack. To create a curved animation, we calculate a midpoint as the midpoint between start point and static endpoint, and raise its y value by curve height to form the peak of the curve. Next, we initialize elapsed time to 0 and use a while loop to animate the coin's movement over the duration of animation duration. Inside the loop, we increment elapsed time by time.delta time to track the time elapsed, calculate a normalized parameter t as elapsed time divided by animation duration, and determine the coin's current position using the calculate Bezier point method. The coin's position is updated frame by frame along the Bezier curve until the animation completes and yield return null. Finally, once the animation is finished, the collectCoin method is called to handle coin collection logic, ensuring the coin is removed and any necessary updates are made. Next, we implement the update method, which continuously checks conditions to trigger the coin collection animation. Inside this method, we first ensure that the animation is not already running by verifying is not animating. Additionally, we check that the backpack reference is not null and that the distance between the coin's position and the backpack's position is less than or equal to the collection radius. If all these conditions are met, it indicates that the coin is within range to be collected. When the conditions are satisfied, we play the coin collection sound effect using audio source.play one shot. We randomize the volume between 0.3 and 0.6 for variety. Finally, we call start coroutine animate coin to backpack to begin the animation that moves the coin to the backpack. This ensures that the coin collection process is visually and audibly engaging while maintaining smooth gameplay logic. Next, we open the Unity editor and assign our coin script to the coin prefab. Then, we add an audio source component to the prefab. From the audio folder, we select the sfx_ui_, click_organic_pop_thin_, generic_1 audio clip and drag it into the audio coin collection field of the coin script. Finally, we adjust the collection radius to 2 and set the curve height to 1. After that, we create another new script called the CoinSpawner, which will be responsible for spawning coins. Double-click and open it in Visual Studio. First, we add a variable coin prefab to reference the coin prefab that will be instantiated during the spawning process. Next, we define an integer array coin counts with values 10, 15, 20, which specifies the possible numbers of coins to spawn. The spacing variable is introduced to control the distance between each spawned coin, and the axis string determines the axis along which the coins will be positioned, either X or Z. Within the spawnCoins function, a random coin count is selected from the coinCounts array using random.range between 0 and coinCounts.length, ensuring variability in the number of coins spawned. A for loop runs for the number of coins specified by coinCount. and inside the loop, each coin is instantiated using the coin prefab at the current spawn position with the determined rotation. The spawning starts at the position of the game object this script is attached to, given by transform.position, with coin rotation initialized to quaternion.identity for default orientation. If the specified axis is Z, the coin rotation is adjusted to align coins along the Z-axis by setting it to quaternion.Euler with values 0, 90, 0. In the for loop, depending on the axis, the spawn position is incremented along the x-axis or z-axis by the value of spacing after each coin is placed, ensuring the coins are evenly spaced. In the start method, we call the spawn coins function to initialize the coin spawning process when the game begins. In the Unity editor, right-click in the scene hierarchy and create a new empty game object, naming it CoinSpawner. Reset its transform, then set its position to 1.4215 on the X, Y, and Z axes. Attach the CoinSpawner script to this game object. Next, drag and drop the coin prefab into the coin prefab field of the CoinSpawner script. Finally, change the axis property to Z to configure the spawner to create coins along the Z-axis, positioning them directly in front of the player for testing purposes. Select the AJ game object from the scene hierarchy and find the backpack game object. Create a new tag called backpack and assign the tag to the backpack game object. Click play. As the gameplay begins, navigate through the scene and slide under the first obstacle. Then, observe the coin collection mechanic. To test the coin collection functionality, adjust the timescale value in the player controller component of the AJ game object to 0.2, slowing down the game for easier observation. Click the play button in the Unity editor to start the game. Then, observe the coin collection mechanic. Since the timescale has been set to 0.2, the game runs in slow motion, allowing you to clearly see the animation as the coin arcs gracefully toward the backpack. This slowed-down view provides an excellent opportunity to verify that the animation and sound effects logic are working as intended. It also helps identify any potential issues or areas for refinement in the coin collection system. This concludes the section on enabling coin collection. In the next section, we will focus on implementing audio effects to further enhance the gameplay experience.